Good morning, ladies and gentlemen. Today we are going to talk about the fire detection and warning system. Before we start, please allow me to introduce my group. I'm Izzy Chen, my group members Xianyu Li and Muntasir. Uh, in this project presentation video, it will include three parts. The first one is project work. It contains the main concept of the project design. The second part is a demo of system. We will show you a demo of what we designed and implemented, and a conclusion at the end. In this project, I mainly focus on the Raspberry Pi setup, Node-RED setup, system configuration, sensor setup, Pi camera, Open Weather Map API, the Node-RED dashboard design, the report, and a video. And Xianyu Li was focused on the back end of the system, the database connection, Blink app connection, and how to generate a safety report, and how to predict temperature by using machine learning. Muntasir mainly focused on the report and the video. So now, please allow me to invite my group member Muntasir to talk about the system purpose.
Fire safety is closely related to economic development and social stability. How to predict and eliminate fire hazards in time is a serious topic of people's concern. An accurate and effective fire detection system can help prevent and mitigate fires. Nowadays, the era of Internet of Things has arrived. With more and more new software and hardware, the development of Internet of Things has accelerated the process of integrating technology into life, enabling people to understand and experience intelligent life. Therefore, the aim of the project is to design a fire detection and warning system which can provide the user a greater likelihood of early detection and notification, so that protecting them from fires including bushfire and house fires. The solution should combine the hardware and software features of Raspberry Pi, Environpath, Node-RED, Blink application, Pi camera, and machine learning.
Hi everyone, I'm Xian Yu. Today I'm going to talk about the system design. The diagram shows a working process of the FDW system for a real user. The user needs to turn on Raspberry Pi to log in Node-RED main page. The user can view all info of the system on the dashboard page. The sensor data will be stored into Firebase and Google BigQuery. The user can view sensor data through Blink app. The notification of the system have two parts, which are email push and phone push. When temperature exceeds a certain value, the system will notify the user by sending an email and push a phone notification. The user will receive a safety report which is generated by Google BigQuery. The data flow diagram shows how the system handles and how the system uses the data from the EVRP head and finally to safety report. It also shows how to combine the hardware and software components to achieve the IoT solution. The project is focused on building an end-to-end solution from collecting data to do analysis on your data. In order to achieve this one, we need to manage Google Cloud Services, give an overview how to build the IoT solution. At the end, the system could build the reports on sensor data and access it through the web. In this project, we are using BigQuery node and a function on the Node-RED to connect sensor data and BigQuery. Within the BigQuery machine learning, users can create and execute machine learning models in BigQuery. Please allow me to invite my group member Ethan to talk about the system core functions.
For the system core features, as shown in the figure above, this image shows the overall workflow of the fire detection warning system we designed. It clearly shows the design of the entire system, which contains 11 core sections. These 11 sections are discussed below. The first one is displaying the real-time data from EnviroP head sensor on dashboard. And second one is email notification and Blink phone notification, LED light notification, Pi camera notification, Open Weather Map. This used to display the current weather data, and fire state analysis, color detection, Firebase, which used to store the online data. The BigQuery, this used to generate the safety report, and the machine learning at the end. I'm going to show you a demo of key functions we designed and implemented. It shows you overall workflow of the fire detection system. It clearly shows the design of the entire system, which contains 8 core sections. So now we are going to display all the functions one by one. The first is display the real-time data from EnviroP head on the dashboard. As you can see, this is our design dashboard. On the top row is the current home condition. You will be able to see all the temperature, pressure, lead level, and even their past 1 hour history from the EnviroP head. Core feature we have is a system notification, and since we are in the study room right now, we are not allowed to use a fire or lighter, so we have to use the hair dryer. So the sensor right now will detect the temperature. So the first notification, as you can see, is the LED light notification. The LED light will capture the current temperature. If reached to a certain level, the LED will turn on. And also, as you can see on the dashboard, the real-time data the temperature also goes very high. So for the email notification, as you can see, it will come up an error message, the warning message. So now, as you can see, you can also receive a phone notification from Blink app, and also turns out a warning message. Yeah. So you can open the message, check what happened. Yeah. So now come out a warning message and click OK. And even in the app, you will be able to see all the home condition like temperature, pressure, and lead level. For the notification system, we have the last one, which is called the Pi camera. So as you can see on the left side, we do have an image that was captured from the Raspberry Pi. So if something happened, or if the temperature achieved certain level, the Pi camera will take the image automatically and display on the dashboard. So the next core feature is Open Weather Map. Open Weather Map is an online open source weather station. It provides real-time weather data including temperature, humidity, pressure, wind speed, and so on in your location. So this function is used to compare with your current home condition and see the outside weather condition, and you can make your own judgment. So as you can see in this case, we have the current temperature and current weather condition, which is clear. And also this image it can automatically change based on the weather condition, so you can make your own judgment. Next core feature and function is a fire detection analysis, which, as you can see, this is on the left red bottom. So this part is used to compare the different temperatures. They are the current home temperature, current scene temperature, and the Pi CPU temperature. For example, as you can see, the home temperature read by EnviroP head is normally higher than the temperature in scene. So this doesn't mean that there's a fire has occurred in your home, because the Pi CPU temperature, as you can see, the green line, which is pretty high. The home temperature is affected by the Pi CPU temperature, and then we will provide you a fire statement. Says like the fire state is normal because your home temperature is higher than the scene temperature, but this can be considered as affected by the Pi CPU temperature. So in this part of design, we only provide you a brief explanation of your fire detection analysis. Another feature we have is a color detection. Because EnviroP head will read the color RGB value, the system will collect this data and display on the dashboard as a background color, as you can see on the left bottom corner. And then, for example, if the background color changed to red and the temperature is unusual, there is probably something happened. So user can check the Pi camera to make their decision. So now I'll show you a quick demo. If I put a red image on the top of the sensor, you will see the background color change to the red.
Choose the Firebase as our database solution. We connect the Firebase by using Python file. And Due to the limited memory space in our SD card, we decided to store our data into the cloud database. I've tried the Mongo database at first, but I failed for some reason, so I have to choose the Firebase as the solution. For each unique key, we got devices info like level, pressure, status, temperature, and time when this data stored into the Firebase. When the temperature exceeds a certain value, the set will change normal to warning. You can also delete any data if you want. This is our Google BigQuery main page, and you can see we are using two data sets, and this table is for storing the raw data from EnVir Head, and this model for is generated by machine learning, and this you can see, and this table is for predict temperature. As you can see, you can simply query every table by SQL query. For example, you just click the run and wait a minute, and they will show the table. The data source of average, maximum, and minimum temperature, pressure, and level are from EnVir Head. It is calculated and updated automatically. In the middle of this report, there are three time series graphs, which are displaying the average temperature, pressure, and level per day. The reason why there are some value is 0 because the Raspberry Pi didn't turn on in those days. The safety report will be automatically sent to the user email, and the user can set up the delivery time from here. There is a scatter chart showing a trend line of the temperature, and its data source is from this table. Now, it is on the rise based on the BigQuery machine learning analysis. There will be three main functions used in machine learning in order to predict the temperature. Before using machine learning, you have to have a dataset which have already inserted some raw data from the EnVir Head. More details in the report. So in machine learning, the first step is creating a model that is used to train the raw data of EnVir Head, and you need to evaluate the model to get the out-of sample error. The second step is evaluating the model we have created. The last step is using prediction function to predict the result through the model, and here is the result table. To conclude, there are some summary features of this system. For example, the system can store data into Firebase. The system can send a weekly safety report, and the system can predict temperature via machine learning. More details can be found on the report.
To talk about the challenges and solutions, basically we lack of the programming skills on the Node-RED and Python, and also the hardware setup issue. It was a big challenge for us to set up the system image, sensor soldering, and camera connection, and also the limited memory space in SD card. And also we have limited time to do this project. We started working on this project from week 7 and only have around 4 weeks to complete this system, which is a big challenge. And also since we have never learned machine learning before, this is the most biggest challenge we have solved it. And for the solutions, the hardware and software we have used was not familiar to us, so we practiced a lot from our labs to make our work easy. We decided to use a Firebase to solve our limited card memory space issue, because Firebase is an online database. All the data will be uploaded to the cloud database and do not take any local space. And for the machine learning, we have used the BigQuery machine learning as a machine learning solution to predict temperature. So what we can improve on this current system? Due to the time restriction and teamwork issue, our project still needs some more functions to be completed. In the future, we consider to implement more sensors such as gas sensor, smoke sensor, buzzer, and so on. And the live stream video will also be considered, so our users can monitor their home condition at any time. Moreover, our team will focus on the deeper use of machine learning to help users avoid the danger of fire. Finally, our team will develop a mobile application within the FDW system to improve user experience on the smartphone devices. And thanks for your attention.